Hey guys, welcome. This is Mr. Harper Smith. Today we're going to be talking about binomial distributions, what they are, and how to calculate them. Okay? A nice way to think about what a binomial distribution is to think of something that has two outcomes. So I'm going to think of something that has two outcomes. Let's see here. I'm going to jump over to this one. Bloop. Okay. Now, one example of something that has two outcomes would be flipping a coin. All right, that's just an example, flipping a coin. I want you to think of a couple others real quick. Remember, get set, go. All right, should have had a chance to think of a couple by now. If you haven't, I'll go through a couple. So one would be flipping a coin. You either get heads or you get tails. Something that would not be binomial distribution would be like a bag with a bunch of marbles that are different colors, red, blue, green, yellow. You could be picking any of those colors. A dice, for instance, has 6 different sides, not 2 sides. So not a dice. Now, there are a couple gray areas. Let me give you an example of a gray area, okay? One gray area would be if we're just talking about a dice and rolling a 6. Well, in that case, the outcomes are either rolling a 6 or not rolling a 6. Now there's 2 outcomes. We could think about one of my favorites is being attacked by a gorilla on your way to school. That has exactly 2 outcomes. You either get attacked by a gorilla or you do not get attacked by a gorilla on your way to school. We're not going to talk about survival rates. Okay? That's something that has 2 outcomes. Getting in a car accident. Either get in an accident or you don't get in an accident. Almost getting into an accident doesn't count as an accident. It only has 2 outcomes. We can think of your grade in a class. If we're just talking about what grade do you have, well, that's not binomial. Something that only has 2 outcomes would be, do you have an A in the class? Something that is a yes or a no answer. When you roll a dice and you're trying to get a 6, you either yes, get a 6, or no, you don't get a 6. So let's look at a couple examples and how we can calculate, how we can determine if something is binomial or not. The best way is bins, B-I-N-S. If you need to pause it and write this down, go for it, all right? So the B in bins stands for binary. Binary means 2. There are exactly 2 outcomes, no more, no less. When you flip a coin, it's either heads or it's tails. It's not belly or anything. It's not hoof, it's head or tails. So if there's only 2 outcomes, then it satisfies this B for binary. We have to satisfy all 4. If it doesn't satisfy one of these, we're out of luck. I stands for independent. Does one outcome affect the next? If I flip a coin and get heads, does it affect the next outcome? Does it affect the probability of the next one being heads? No, the next one is still 50% heads or tails. Okay. N stands for number. There's a set number of trials. You don't keep going on until you eventually get heads. You're going to flip a coin 10 times. And you're just going to count how many times it goes heads. It could be 0. Could be all 10. Is it likely that it's 0 or 10? No. It's more likely going to be like 5 or 6, which we'll actually get into here a little bit later. Then finally, S is that each trial is the same, or each trial has the exact same probability. For example, flipping a coin, each trial has a 50% chance of being heads. That's it. Okay? So bins. So let's look at an example and determine, is this binary? Is it going to be a binomial distribution or not? So B, binary. If I roll a dice 10 times and I'm counting how many 6s, is that binary? Is that something that's a yes or a no? It is. That is binary. You're just counting the 6s, okay? Each time you roll the dice, the answer is yes or the answer is no. That's it. I stands for independent. Is each roll independent from the previous roll? Yeah. If I roll a dice and get a 6, the probability of the next one being a 6 is the same as the first roll, as it will be on the 3rd and 4th and 5th roll. It stays the exact same every single time. That's the beautiful thing about binary, is it's always the same. Next up would be N, the number Is there a set number of rolls that we're going to look at here? Yeah. How many? 10. If you said 10 before me, good job. I'm so proud of you. All right, then finally is S. Does each one have the same exact probability? It does. All right. So this would be a binomial distribution. Let's look at another one. Shooting a basketball 20 times, assuming that you're going to be staying the same roughly each time. You're going to do it from various distances of the court, and we're going to let y equal the number of shots made. Is it binary? Or in other words, is the answer either yes or no each time? Well, I shoot the ball, and I either make it or I don't make it. There's no in between. Okay, if it bounces off the rim and doesn't go in, you didn't make the shot. If it bounces the rim and goes in, well, it went in. So there's only two answers here. So that is binary. Next up would be I. Is it independent? Does each shot, sorry, not does each shot, does one shot affect the probability of making the next shot? In your mind, it might a little teeny tiny bit, but in reality, no, it doesn't. If you're good at basketball, each shot will be independent. If you miss one, it's not going to mean you're going to miss the next. If you make one, it does not mean that you're going to make the next. Each one is independent. N, is there a set number of shots? In this case, yes, there are a set number of shots. We will be shooting exactly 20 times. Okay, so N checks off. So far, the first three checked off. It's binary, it's independent, it has a set number. So do we think it's going to be binomial? Well, let's check the last one. Does each shot have the same probability? No. What, Mr. Harper-Smith? What do you mean no? Of course they are. It doesn't, and it's a word in here. It says various distances on the court. If I'm shooting from the three-point line, do I have the same probability of making it as I do from the free throw line? No. I'm shooting from the free throw line. Do I have the same probability of making it as I do from the half-court line? No. Well, unless you're Mr. Harper-Smith. I can't make it even if I'm right next to the net. So in that case, my probability is always 0. Hey. So in this case, this would not be a binomial distribution. Okay? This would be something else. Binomial, each one has to be the same. Kind of like with flipping a coin. Every single time, it has to be the same probability. So I want you to try this one. Pause the video. I want you to determine on your own, is this going to be binomial or will it not be binomial? Okay. Pause it now, then I'm going to give you the answer. All right, you should have paused it. The answer here is, let's read through it. If X is the number of sixes in three rolls of a dice, where N is 3 and P is 1/6, well, B, is it binary? Yeah, it's a dice. You're just counting how many sixes. I is independent. Well, we've already talked about dice not affecting each other, so it is independent. N, is there a set number of rolls? Yes, there are 3 rolls, so it does have a set number. Then finally, S, is each roll going to have the same probability of success, the same probability of getting a 6? Yeah, it's a dice. So in this case, would this be a binomial distribution? It would. Okay. Now let's change it up a little bit. For this, you're going to need your TI-84 calculator, whether it be the Wabbit emulator. I like how they say Wabbit. Wascally Wabbit. So we need our Wascally Wabbit emulator, or if you're on the Apple, it's the graphing calculator X84, whichever one you decide to use. Or if you have an actual TI-84, you can use an actual TI-84. I've got multiple TI-84s here. I don't have any Inspires. I'm sorry. You can do this on a TI Inspire though. Just look up the instructions online. All right, so here's what's different this time. Instead of determining if this is binomial or not, because we've already determined that's binomial, we will be determining what is the probability. So in this game, we're rolling a dice 3 times. We want to know what's the probability of all 3 of those dice not being a 6. Right here, X equals 0. That means none of those dice rolled a 6. Okay, there were 0 successes. Well, to do this, let's open up our calculator. Okay. I'm going to make sure that mine is sharing the correct screen with you. There we go. So we need to turn on our calculator, and we're going to go to second variables. So basically, it gives us a distribution because we're talking about binomial distributions. All right, so your screen should look something like this. Then scroll down, and we want the binomial PDF. Next lesson, we're going to learn the difference between PDF and CDF. CDFs are pretty easy. So are PDFs once you understand them. Okay, so we're on binomial PDF. I'm going to hit enter. Now yours is probably going to pop up a really nice menu where it's going to tell you the number of trials, the probability of success, and the number of successes. Well, in this case, our number of trials is how many times we're going to roll the dice. How many times do we roll the dice? 3. Okay. So on yours where it says trials, you're going to put a 3. Then the next one is going to represent the probability. What is our probability in this case? Well, it's 1 out of 6. That's the probability of getting a 6, isn't it? Each time, that's the probability. Comma. Now the last number that we're going to put in there is how many successes we want. How many 6s do we want to roll? Well, in this case, we want 0. So we want 0. You close the parenthesis. Now, before I hit enter, I'm going to think about this. Is the probability of rolling a 6 very high? It's not. So if I roll a dice 3 times, am I really likely to get a 6 or just kind of likely? My guess is it's going to be somewhere around 50%. So you figure on a dice, 1/6 is going to be the probability of getting a 6. And if I'm doing that 3 times, well, 3 out of 6 is roughly 1/2. So my guess is somewhere around 1/2. That's not how the math works at all. It doesn't work anything like that, okay? But it's going to be somewhere around 1/2. If I get some crazy number like 90%, I'm going to know something's wrong. I calculate it, I get a 58%. There's a 58% chance that 0 of those dice will roll a 6. Okay? 0 of them. So let's try another problem. Let's try if we want to get 1/6. Well, if I want to get 1/6, how do I need to change this calculator? What do I need to change in the formula? Do I need to change the 3? What did the 3 represent? The 3 represented the number of rolls. Well, if we're still rolling it 3 times, do we need to change the 3? No, we don't. So we leave it at 3. Next up is the 1/6. That is the probability of rolling a 6. If we just want 1/6, does that change the probability of rolling a 6? It doesn't. So the 1/6 stays the same. The only thing that changes is the number of successes. How many X's, how many 6s we want. Not X's. I'm sorry. How many 6s? X's would be like you're no longer dating somebody. How many X's do you want? That's kind of a sad question to ask. So 0, we're going to change to a 1. That's all you got to do. All right, we want 1 success, and I hit enter. 35% about. Okay, so about 35% of the time, if you roll 3 dice, exactly 1 will be a 6. Okay, there's a set number of outcomes that we are wanting. It's binary. All right. Next up, let's talk about averages. You know what? Before we do that, I want you to try a problem. Okay, what will the probability be for rolling exactly 2 6s if we roll 4 dice? So we're going to roll 4 dice. What's the probability that exactly 2 of them will be 6s? Give it a try. We're rolling 4 dice. 2 of them are 6s. What's the probability of that happening? Well, we've got 4 dice that we're rolling. We want 2 of them to be 6s. My guess is it's not a very high probability, but I might be wrong. It's about 11%. Is it very likely that it's going to happen? Not very likely, okay? Could it happen though? Yeah. 1 out of every 10 times that you roll 4 dice, 2 of them would be a 6. Cool. Not very often though. All right, so let's try this next little bit. This next bit is on averages. I'm gonna make sure that you guys can see the screen. All right, so here's the screen. Expected value. Now we've already gone over expected value. Expected value is just an average. That's all expected value is. On average, how much money do you expect to make? How much money do you expect to lose? In this case, though, if you roll 3 dice, how many would you expect to be a 6? Let's change the number a little bit. If you roll 6 dice, I'm rolling 6 dice, how many of those dice will be a 6 on average? Well, there's dice for 1, 2, 3, 4, 5, 6. My guess is that 1 on average would be a 6. Let's try out this formula. Mu is the average. Okay. N stands for the number of trials. So how many dice are we going to roll? And P is the probability. So N in this case, if we're going to roll 6 dice, I'm going to do 6 times P, or 1/6. That's going to tell me on average how many 6s I'm going to get. Well, as I hit enter, it tells me 1. So if I roll 6 dice a whole bunch of times, and I averaged out how many times it was on average, I would have an average of about 1 6 per roll of 6 dice. I roll 6 dice, on average, 1 of them is going to work. What if I have 12 dice? If I roll 12 dice, how many do you think are going to be a 6 on average? Think about it for a second. Let's do the math. Okay, I'm going to do 12 times the average. Or sorry, not the average, the probability. 12 times 1/6 gives us 2. Doesn't that make sense, though? If you have 12 dice, you roll them, and you have it broken up into 6 segments. Well, that's 2 per segment. So you're probably going to get about 2 6s. All right, let's try a bigger problem. Let's say if you have 100 dice. Okay, so let's change this number right here to 100. I want you to do this one on your own. How many 6s would you expect to get? How many 6s would you expect? I want you to try this one. This one's on you. How many 6s would you expect if you are rolling 100 dice? Okay, here goes the answer. We're going to do 100, which is n, how many trials we have, times the probability, times 1 divided by 6. That gives me what? 16.6, so roughly 17. If you had to place a bet on how many 6s you thought it was going to be, about 17 would have been your best bet, to be honest. Okay, there's one last piece that we need to go over, and it's on standard deviation of a binomial distribution. Okay, make sure to write this down. Sigma right here stands for binomial standard deviation. Okay, you should have it written down by now. So here we go. The standard deviation is how much it varies from the mean on average. So when we're thinking about the example with 12 dice, when there's 12 dice, we expect 2 of them to be a 6. How much does that vary on average? Well, let's find out. We're going to take the square root. What does the n represent? The number of trials. So if we're doing the example of 12, then we're going to multiply it by p. What's the probability of getting a 6? It's 1/6 every single time. Then 1 minus 1/6. Then you close all your parentheses. Let's see, I opened parentheses twice, I close them twice. If you have a newer TI-84, you don't need to worry about parentheses, it's just cool. We hit enter, 1.29 on average. So on average, it's about 1.29 higher or lower. Okay, that's roughly where it would be. All right, let's look at another example. Let's try with 100. You're flipping a coin. All right. Well, let's try this one. I'm going to do this square root of n, which was 100, times p. What is my p if I'm flipping a coin? What is p? The probability. What's the probability with a coin? It's 50%, 0.5. Okay, you can do 1/2. You do 0.5. Then we do 1 minus 0.5. Hit enter. It tells me 5. So that's the standard deviation. That's how much it can vary from the average. All right, this last one's all you. Give it a try. Find the standard deviation of rolling a 3 on a fair-sided dice with 36 trials. Okay, so you roll a dice 36 times. You're counting how many 3s? What is the standard deviation? How much will it vary from whatever its average is? Let's go for it. All right, you should have paused it by now. You should have your answer. We're going to do the square root of 36 times 1 divided by 6, 1 minus 1 divided by 6. That gives me 2.23. That's it. Okay. Not super duper hard with these. If you remember the formulas. If you don't remember the formulas, this can be very, very tricky. So make sure to write down the formulas that we have in this video so that way you can use them. All right. Give it a couple questions coming up a try.